Welcome back, Dylan. It's good to have you today.
I've never been here before.
I'm glad that I could host you today in my house. With that, I'd like to introduce today's topic to you. What is your opinion of water?
I don't know what it is.
Well, it's perfect that you came here, Dylan, because I think you will learn a lot of information today about this glorious liquid known as water.
What's that?
Well, you know what? I appreciate your inquisitive questioning, Dylan. Okay, well, water is found in various forms in our environment. We do have the water cycle. One of the most underappreciated things about water is just how important it is in the grand scheme of things, planet Earth, like the cell. I'm kind of here today to help educate you about this because as someone who is unaware of dihydrogen monoxide. I am a debunker, okay? If there was a bunk bed, I take the top bunk off. I debunk. I debunk these myths.
Okay.
Okay, it's a bunk bed of myths, and I'm taking the bunk off.
You are, as someone would call, a mythbuster.
Myth bunker. So, I'll start, it's just a fascinating molecule, Dylan. I really want you to see just how much I like it. It makes for a lot of uses. All right. Well, I think water has.
Tell me all you know.
It has some very fascinating qualities, Dylan. Now let's take a look at its name. Okay.
Water.
Now, if you break down the word water, you get H. Put an H in post production over my hand.
An H.
Yeah.
Okay.
Okay. Here, two H's. H2. Put an H. Two H's over my hands in post production.
Okay.
Alright, H2O, angle it, put an O right here. It's made up of two hydrogen molecules and one oxygen molecule. What this allows for is a phenomenon known as hydrogen bonding.
Yes.
Now, hydrogen bonding is one of the keys.
Two hydrogens, they meet in a bar, one gets a little tipsy, they get bonding a little bit, and then takes the other one back to its place.
And ultimately, they become lifelong friends.
Okay.
Although, it's unlikely that will happen because hydrogen bonds are only about 15% in terms of how often they're occurring.
Oh, okay.
So they don't necessarily create strong bonds. It's a relatively weak bond. So I would say they'll likely form acquaintances. So what this hydrogen bonding does is that in the case of a body of water, just put a body of water here in post-production.
I'm not sure if I can do that, but I will.
Okay.
We'll see how that goes.
The surface tension is caused by when you see one of those water skipper things.
Okay.
That is basically playing off of the tension on the surface of the water. And that tension is caused by those weak hydrogen bonds happening right at the top that basically hold the water molecules together and make it like a sheet.
Yes.
A small sheet. So that's why it happens. But they are weak, and that's why we cannot.
We cannot what?
A hydrogen bond can last only a few trillionths of a second.
I once bonded with a hydrogen. She did not like me very much.
Another thing that's really important about water is something called its high specific heat. Now, Mr. Dillons, do you know what high specific heat is?
It's the heat that is specifically high.
Is the amount of energy that needs to go into something, 1 gram of something to change its temperature by 1 degree Celsius. So water's is 1 calorie per gram per degree Celsius. So
calories like those things that I have in my chocolate bars.
Yes, they are the same measurement, but they are a bit higher in terms of range. The calories you see on your food is I think about 1,000 of these traditional calories. Now ask me why it's important.
Why is it important?
Well, Dylan, I'll tell you why it's important. A high specific heat means that the water takes a while to heat up, which is pretty much by definition. But in the case of large bodies of water, like the oceans, some water-based planet, it means that it takes a while also for the water to release the heat energy. So because it takes a while for the heat to get in, once it gets there, it's going to stay there. And because of the natural currents So what basically happens is, as it's carried through these currents, the heat is slowly released along the current line up north where it's colder. So it's almost like a climate control for the Earth, is the fact that it can carry the heat from one place to another, and that's really important. So Dylan, you remember also how I was talking to you about the hydrogen bonds that were happening?
Yes.
Well, similar to the fact that they create the surface tension on water, that's because of an effect of the hydrogen bonds called cohesion.
Yes.
So cohesion also affects plants, because the water, as it's going up through a plant, it needs to be able to hold itself together, the kind of body of water within the plant. It needs to be able to stick together, so it can also act on another property called adhesion, which is its ability to kind of stick to things.
Like tape.
As it's like tape. Tape is an adhesive, as you could say, or peanut butter.
I would not say.
So the adhesion basically allows water to resist gravity's effect, because you have it clinging to just put the xylem root, or like the xylem things, xylem tubes of the plant, just draw one right here.
All right, I will.
So it's basically being drawn up against the pull of gravity, and it's each thing of water is clinging to the other through cohesion, but also clinging to the walls through adhesion to get to the top, where it can be another quality of water, which I'm still really surprised you don't know about, because it is all around you, is its high heat of vaporization. Now, Dylan, let me ask you, have you ever taken a really hard test?
I'm sure I have.
Have you ever been just dripping grotesquely with sweat afterwards?
One could say that has been a truth, yes.
Alright, well, what happens there is it's just your body sweating. But your body is basically taking advantage of this property of water, because water has a very high heat of vaporization compared to other liquids, which means it can evaporate into the air quicker. The hottest molecules can evaporate. Similar to if the hottest molecules on your body are evaporating, the temperature of your body would, in theory, be lower on average.
That would also be correct.
As that process continues. Yeah, exactly.
I don't know, are you asking me a question? You're just saying words.
So the last thing we're going to talk about is when water's in its liquid form and it gets really cold and it freezes. And this is when you put ice in water.
What's ice?
Ice is a frozen form of water, Dylan.
Okay.
Okay,
so an icy.
Without the flavor. It's a plain icy, but melted.
That sounds awful.
They are. Imagine that there is a cube of the non-flavored melted icy. So you have, so let's put this together.
Wouldn't melted icy just be non-flavored liquid icy?
So you have non-flavored liquid icy, and then you have frozen icy.
That's also non-flavored,
and you put that
into the
liquid non-flavored ice. Okay. The non-flavored frozen icy will float, actually. Now, what happens to these molecules is that when they're frozen, they form kind of a crystalline structure with their hydrogen bonds that makes them actually 10% less dense. Which, since it's less dense than what it was before, it's going to go up in the solution, or the body of water that it was in. So it'll float up. So what's interesting about this is that you can have giant non-flavored melted ices, bodies of water around that have non-flavored frozen icy on top. But the non-flavored frozen icy is actually a very good insulator. So it keeps the liquid underneath it at a manageable temperature, so that the life underneath doesn't freeze up and die. So that's very important, because otherwise we'd have extinctions, massive extinctions around the world every year, and we don't want that. Water is also a very good solvent.
What is that?
A solvent is
it solves mysteries.
Yes. Sherlock H2 Holmes. Imagine you have a cup filled with water.
I don't know why I would have that.
And within it, say you put something.
Yeah.
Pick something.
A cat.
I heard you say table salt. So say you put the salt into this water. It's going to dissolve very nicely, because you're going to have the different parts of the H2O molecule, that is the water, pulling off the different ions of the NaCl table salt molecule. So because of its ability, it's very good at dissolving things. Water is all around us, though. It's in your pool, it's in a lake, ocean, your body.
Don't know where.
Yep, everywhere. So no matter where you go, you will find water because you need it. Otherwise, you will die.